This video is for section 7-12. We're going to solve equations that have radicals. You probably have noticed in every chapter we've done this year in Algebra 2, we've always concluded the chapter with a section about solving equations. So one time we solved an equation that had fractions. In another chapter we solved an equation that had quadratics in it, and so on. So this time we're going to solve equations that have radicals in there. The process is given here on the screen. Number one, get the radical term alone on the left side. Step 2, raise each member to a power that matches the root index. That will remove the radical. So if it's a square root, you raise to the second power because squaring cancels away square root. If it's a cube root, raise to the third power because cubing cancels cube root, and so on. After you've solved and got answers for x, check using substitution because the answers you get could be extraneous. This has happened earlier this year as well, where sometimes we do everything correctly, but the answer we get is not actually in the domain. It's a restricted value. So we need to check for that. Let's do a couple examples and follow through that three-step process. So the first step was to get the radical term alone on the left side. Here's the radical term. So first we could subtract the 2. And we could add the y. So we have negative 2 square root y plus 1 is equal to y minus 2. We're moving the y to the other side by adding it. We're moving this 2 to the other side by subtracting it. Next step, let's remove the coefficient on our radical term. Divide by the negative 2. We have the square root of y plus 1 is equal to y minus 2 divided by negative 2. Now we're ready to get rid of the radical symbol. The index of a square root is a 2, so that's the power you raise to. Square that side and square this side. Now you just get the radicand, y plus 1, and that's equal to y minus 2 over negative 2 squared. We could simplify this out a little bit. This makes y minus 2 squared on the top all over 4. Let's actually expand the y minus 2 squared. So we get y squared minus 4y plus 4 all over 4. Now we can subtract 1 from both sides. We get y equals y squared minus 4y plus 4 all over 4 minus 1. Let's change the 1 into the fraction 4 out of 4 so that it has a common denominator with this first fraction. We'll go up here and continue our work. Y equals y squared minus 4y plus 4 all over 4 minus 4 over 4. Because we now have common denominators, we can actually combine our numerators. We have y equals y squared minus 4y all over 4. Next step, let's multiply the 4 to remove the denominator. We have 4y equals y squared minus 4y. This appears to be a quadratic equation because of the highest degree of 2. Let's get standard form by subtracting 4y from the left side to make a 0 there. We have y squared minus 8y. At this point, we can solve the quadratic equation with factoring or completing the square or the quadratic formula. I'm going to use factoring because both terms divide by y. So we have y times y minus 8. From the first factor we get y equals 0, and from the second factor when we solve for y, we get y is equal to 8. Now we need to check both of those answers into the original problem that's typed in black ink here to see if they actually work. Let's try the 0 first. 0 plus 1 makes a 1, and the square root of 1 makes a 1. 2 times 1 makes a 2. So this whole part right here, that's 2. If we put a 0 right here, we have 2 take away 0, take away 2. And that does equal 0, so this answer checks out. Now let's try y equals 8. 8 plus 1 makes a 9. The square root of 9 makes 3. And 2 times 3 makes a 6. This whole part right here is a 6. Remember, we're also putting 8 here. So 2 take away 8, take away 6. That's not 0. This answer does not work. You have to cross it out. That answer, y equals 8, is an example of an extraneous solution. It's a number obtained by the solution process, but it doesn't actually work when you check your answer using substitution. Let's try one more example. To solve an equation that has more than one radical term, you might have to raise to a power more than once. Here we have an example of that. On the right side, we have our radical isolated, but on the left side, there's 2 separate terms. And there's no way to fix that right now. Like if we tried to add 1 over to this side, we would get 1 term on the left, but then suddenly we would have 2 separate terms on the right. So this is going to be a problem that takes more than one step of raising to powers. How do you get rid of square root? You square both sides. So square the left side and square the right side. To square a binomial, you use FOIL, or the shortcut version of FOIL. Square the first term, that makes x. Then double the product of the 2 terms, right? So times these together, that's the product of the terms, and then you double it by putting a 2 in front. Then square the last term, that makes positive 1. On the right side, where there only was 1 radical, when you square it, that cancels the square root, and you get 2x plus 1. Now we have a problem where we can isolate the radical term. Let's subtract the x and subtract the 1. We get negative 2 square root of x is equal to x. Remember, we were subtracting x, so 2x minus x makes an x. And we were subtracting 1, so this 1 subtract 1 makes nothing. Next step. Let's divide by negative 2 on both sides. We get the square root of x is equal to x over negative 2. Now we're ready to remove the radical by squaring. You square both sides of the equation. Squaring a square root makes the radicand. And over here we get x squared over 4. Let's multiply by 4. So we get 4x equals x squared. This is a quadratic equation, so let's make standard form. Subtract 4x from both sides to get a 0. We get x squared minus 4x is equal to 0. This one happens to factor again, so let's use factoring. X times x minus 4 is equal to 0. Our first answer is x equals 0. The other one is x equals 4. Remember, we have to check because maybe it doesn't work. Let's try our answer of 0. The square root of 0 is 0, and 0 minus 1 makes negative 1. When you put 0 over here, you get 2 times 0 is 0, 0 plus 1 is 1, and the square root of 1 makes positive 1. These are not the same. This answer doesn't work. Cross it out. Now let's try the answer of 4. The square root of 4 is 2, and 2 take away 1 makes 1. Now over here, 2 times 4 is 8, and 8 plus 1 is 9, and the square root of 9 is 3. Those aren't equal either. You have to cross it out. We don't have any other choices, so this one is empty set. Let's summarize the lesson. We solved equations that have radicals in them. Our examples had square roots, but certainly they could have been cube roots or fourth roots or whatever. That doesn't matter. The process is still going to work. Isolate the radical so that you can then raise to a power that matches the index of the radical.